Hello everyone. Today there is another gate problem on pile foundation. There is a question, a group of 9 piles. So total piles are given. So total number of piles n equal to 9, and it is in a square pattern 3 by 3. So the pattern is going to be like this. 3 by 3 pattern is embedded in a soil strata comprising dense sand underlying recently filled clay layer. So, if you take the sectional view, with the ground level, GL, and here comprising of dense sand underlying recently filled clay. So first it is filled up clay, and then underlying it is dense sand. So this is the filled up material, and that is clay, filled up clay. The perimeter of an individual pile. So the perimeter P of single pile is given over here, is 126 centimeter, that means 1.26 meter. The size of the pile group is 240 centimeter by 240 centimeter. So pile group, if you take it, the size is 2.4 meter by 2.4 meter. So that is the size of the pile group. The recently filled clay has undrained cohesion of 15 kilopascal. So you have got undrained cohesion of 15 kPa, and the unit weight, so this clay has Cu equal to 15, and the unit weight, that is gamma, is given to you as 16 kilonewton per meter cube. The negative frictional load acting over the pile group is to be calculated. So, what is the negative friction in kilonewton for the pile group? That needs to be calculated. So, this is the total diagram, and you can calculate for a individual shear condition. You know that the negative friction, here the negative friction because the pile is this clay is going to settle, and the negative friction that is going to develop for a single pile also you can find out, and you can find out for the pile group. This is for the group, and this is for the single pile. So for a single pile you can find it out, and also for the pile group you can find it out. So for the pile group, it will be number of piles into negative friction of a single pile. So you can multiply it. So number of piles are known to you here. So you can calculate based on individual shear 9, and this for the single pile it will be the perimeter of the pile, single pile, and the friction is going to develop over the perimeter. So perimeter into, let's say this filled up ground, this length is Ln for negative skin friction. This length is Ln, so multiplied by Ln, that becomes the area, multiplied by the skin friction that is going to develop. So that means it is going to be alpha times Cu. That's the negative skin friction that's going to develop it. So it's acting in the downward direction. That is the drag force that is going to act. So now there is going to be 9 piles, and the value of PS is 1.26 meter, and the length of the filled up ground is given in this problem as 2 meter. So you can take this as 2 meter. So if it is 2 meter, Ln is known to you as 2 meter. It's given in the problem itself in the diagram. So it is 2 meter, and the value of alpha here is to be taken as 1, and then you can find out the value of the Cu, and the value of Cu is already given as 15 kilopascal. So into 15, so 15 kilonewton per meter square. So this becomes so much of kilonewton. So if you simply calculate it, you will be getting the answer based on individual shear, and then you can also find out based on group shear failure. So negative skin friction of the group is where the negative skin friction, it is going to be formed on the periphery. So you will have to find out what is the perimeter of the group. So perimeter of the group, you should find it out, and perimeter of the group you can calculate it. It will be 4 times width of the group, and width of the group is given to you as 2.4 meter. So perimeter of the group is known to you, 4 times Bg, and here on the perimeter multiplied by the length. So Ln is given to you as 2 meter, so you should multiply it by Ln, length of this, and then it is the frictional component will be alpha times C. So if you calculate it, this will be 4 into 2.4 meter into 2 meter into 1 into 15. So this is the group capacity based on group shear failure. As a whole, if you take it, this drag force is going to act on the periphery. So this is the calculation. So we can calculate it, and if it is the single individual shear failure, then this formula should be used. So these two formula you will be using to calculate the negative skin friction, the negative frictional load in kilonewton, these two formula, and the greater of the two will be taken, the maximum value will be taken. So let's calculate it. Based on individual shear, it is 9 multiplied by 1.26 into 2 multiplied by 15 is 340.2 kilonewton. And if you calculate this is going to be based on Cook 4 into 2.4 multiplied by 2 into 15. Plus here you should take the self weight of this clay soil. So self weight. So this part is going to be 288, then plus. Now what would be the self weight? Gamma is given to you. So gamma multiplied by volume of this. So what is the volume of the clay? Self weight of the clay in this zone will be how much? Gamma into what is the area? Area is going to be 2.4 by 2.4. So take it 2.4 by 2.4. And what is the height? It is 2 meter. And gamma is given in the problem as 16. So this plus, so we will calculate this plus 16 multiplied by 2.4 into 2.4 into 2. 472. So this part, if you add it, the final answer we are getting is 472.32 kilometer. So based on group shear, this formula you should use it. That is equation 2. Based on individual shear, you should use formula number 1, where number of piles 9 you have taken, and you have found out the negative skin friction a single pile can carry. So perimeter of the single pile into the compressible zone, that is Ln, and then you should multiply it by the frictional or the drag force, that is alpha times Cu. The value of Cu, as you know, is only 15, so alpha value will be 1, so it gives you 340. And here on group, we are taking the complete perimeter of the group because the drag force is acting on the periphery. So when it is acting on the periphery, you should take the perimeter of the group, that is 4 times, because it is a square pattern, it will be 4 times the width of the group. The width of the group is 2.4 meters, so 4 into 2.4, and the length of the compressible zone is 2 meters, so you multiply it by 2, multiplied by the skin friction that is getting developed, that is alpha, into Cu, plus the self weight of this clay which is acting the force in the downward direction, and that will be gamma into volume of the clay mass, that becomes the weight. So volume is going to be 2.4 by 2.4 into Ln. So finally you get, so which is greater out, this is number 2 and this is number 1. So out of these two, the greater value should be taken. So we will be taking the greater value and so maximum value will be the negative frictional load, that is UNF equal to 472.32 kilometer. This is the answer. So this is how you should proceed. Thank you very much.